Welcome back, everyone. To continue on our space theme talks, I'm thrilled to introduce you to Christopher Hadley, Head of Industry, Procurement and Knowledge Transfer. Before joining CERN in July 2021, Christopher spent 21 years working with the European Operational Satellite Agency for monitoring weather, climate, and the environment from space. Thank you, Chris.
Good evening, everybody. So it's my pleasure to introduce to you this evening Professor Grzegorz Wrochna. His first time at CERN was in 1983 as a summer student. Then in the 1990s, he works at CERN on the design and construction of the CMS experiment at the LHC. Since 1999, he's worked at the Institute for Nuclear Studies in Poland, since 2006, being the director. In 2011, he initiated the creation of the National Center for Nuclear Research, the NCBJ, and then became its director. Greg Wrochna serves as Undersecretary of State in the Ministry of Science and Higher Education. He's currently the president of the Polish Space Agency, so clearly a very knowledgeable person to talk on this subject. There will be a 20-minute presentation followed by 10 minutes questions and answers. So please, as usual, put your questions in the chat for consideration. And please, Grzegorz, the floor is yours. Thank you.
Thank you very much. Welcome, everyone. Just before the break, Sean got a question whether the work on space missions is similar to the work on particle physics. And in fact, all my presentation will be an answer to this question, because I'd like to tell you how my work at CERN prepared me for the current job of the president of Polish Space Agency, and in fact guided me to this job. If I could show my presentation, it would be easier for me to explain you the way. In fact, my interest in astronomy started already in my childhood. I was always curious about the surrounding world, what is going on around, why, and I was reading many books. In fact, I have read the first book on astronomy before I went to school. Then I follow closely the missions of Apollo, of Soyuz space programs. And even in the secondary school, I got a second place in so-called astronomical Olympics. You may think that it was natural for me to choose astronomy as a subject of my study. Not at all, because at that time, it seems to me that astronomy is at its end, in fact. Because the telescope, they reached the atmosphere limits. I mean, the fluctuations of the atmosphere caused that the telescope could not reach farther into the deep universe. So I thought astronomy is over. Of course, a few years later, I mean, it was adaptive optics was invented. So again, the telescope from the Earth could look farther, but also space telescopes were launched. You all know Hubble Space Telescope, okay? So after a few years, this statement was no longer true. But I was already a student of physics. And especially I got interested in particle physics and nuclear physics because it is just nuclear physics and particle physics which made us able to understand what is the evolution of the universe from the very beginning, from the Big Bang. What is happening inside the stars and so on. Therefore, I decided to study physics, and in particular the particle physics. Therefore, already during my study after the third year, I went to CERN and I spent 2 months at CERN as a summer student. I worked on the test beam, calibrating electromagnetic calorimeter modules for the UA1 experiment. You can see on the picture one wedge of the calorimeter at the test beam, and on the bottom you can also see the terminals to the computers of that time. By the way, The group I work on was led by PhD student at that time, Fabiola Gianotti. So the next visit to CERN was in 1991, and it was a rather long visit because it took 7 years. It happened that my older colleagues from the university, they went to CERN to discuss future experiments for the Large Hadron Collider, and they decided to join the CMS experiment. But the deal was that the Polish team should provide someone being at CERN permanently to be a kind of a liaison between the group in Poland and people at CERN. So the colleagues told me that I have to finish my PhD very quickly in a month or two, and I should go immediately to CERN. And indeed, on one Friday, I have defended my PhD thesis. Then on Saturday, I have made a party. And on Sunday, I was already at CERN. And I stayed there for 7 years. But in total, I worked for 18 years. So 18 years of my life, it was connected to CERN, just to CMS experiment, in fact. So I was busy with simulating of the tracking and the muon system. I became later the coordinator of the first level muon trigger. So I was responsible for the design of different components of this trigger. Also, I participated in testing equipment with proton beams, both detectors and the electronics. And this was a very important time for me. And what I have gained, what I have learned during this time, I will show you later. And I will tell you how this affected my whole career. You can see me during the construction of the magnet yoke of the CMS experiment. I'm not really turning this screw, but in fact, the thickness of the red blocks here was just the result of my calculations. So, what kind of skills from CERN turned out to be useful in my later career? I will mention both hard skills and the soft skills. I mean, on the hard skills, of course, work with particle beams, radiation safety, designing and testing rad-hard and rad-tolerant electronics, very important for the satellite missions, analysis of huge amount of data, real-time or almost real-time analysis. So you can see on the picture the muon trigger electronics we have developed at the time, and our Minister of Science of the time, you see, he got really enthusiastic about this electronics. But equally important are the soft skills, and those are concerned with running large, long-term projects, dealing with risk in innovative projects, working in international environment, coordinating distributed teams. Let me just make few remarks on those skills, because I believe those are really important for my later work. Long-term projects, in fact, when the first designs of the experiments were presented in Avião, I couldn't attend this meeting because at the same day, my youngest son was born in the hospital in Geneva. So I rather attended the second event. But then when the experiment began to take data, I mean, my son was already in the age that he could make a PhD from this experiment. Well, in fact, he went to IT, not to particle physics. But it shows that those experiments are planned for at least 2, if not 3 generations. So really long term. And the same is with space missions. Dealing with risk in innovative projects, I remember that we have designed electronics which was not possible to build at the day we designed it, because it was obvious that what we designed today, but when we need to build it 5 or 6 years from now, then it will be already outdated, and we need more computing power in one chip. So this was a big risk, but following the trends in the electronics, I mean, we predicted correctly the trends, and finally we were able to build this electronics on time. Coordinating distributed teams. Yes, I think you all know that in fact WWW, what we call the internet today, was invented at CERN just because of the need to coordinate distributed teams working on the experiments at CERN. So what happened next? In the meantime, I attended a joint conference of European Space Observatory, CERN, and European Space Agency. And this was a great inspiration for me because during this conference, I thought that one can use methods developed for particle physics in astronomical observations. And indeed, after some years with Professor Mankiewicz, we created an experiment we called Pi of the Sky, because the idea was to observe a big pi, maybe even pi steradians of the sky, to search for optical counterparts of gamma ray bursts, which are in fact great cosmic explosions, usually caused by super heavy star collapsing down to the black hole, or by a merger of two neutron stars, again end up with creation of the black hole. So we have created this experiment literally from scratch. You can see me with the construction on the left, and this cube skeleton. You see the full cube on the right picture together with our apparatus and the donkey in the Las Campanas, Chile. This was the desert, but the desert was from time to time occupied by animals like this donkey. So this was a wide-angle camera making almost real-time analysis, like in particle physics, and saving only some amount of data, only selected events, only selected part of the pictures. So this was really a different approach than so far used in astronomy. When in astronomy, the data was taken and analyzed usually a long time after the observation offline. And this was a very successful approach because we observed, in fact, creation of a black hole, most probably. You can see a little movie on the left when we observe that some star-like object is appearing. And it was very important that we have observed it even before it was observed by satellites in gamma rays. So usually the signals from the satellites were coming to the Earth, and then telescopes on the Earth follow the signal, but they were able to observe the phenomenon only some minutes after it really happened. In our case, we were able to observe even before. So it was a kind of a breakthrough. And a couple of days later, I got a phone call from NASA proposing as a common paper in Nature. So this is how particle physics already helped me in astronomy. When I came back to Poland, I became the director of Institute for Nuclear Studies, later National Center for Nuclear Research, a big organization, 1,100 employees. So you see, it is almost on the scale of CERN, publishing 500 articles per year and operating a nuclear reactor, producing radioisotopes exported to something like 80 countries. We also produce accelerator parts for CERN, for DAISY, for XFEL, free electron laser. We also produce some detectors for space missions. And you can imagine how much the experience at CERN, both the hard and soft skills, were helpful in this work. And then after that, after 2 terms of being director, so 10 years together, I was appointed as the undersecretary of state in the Ministry of Science and Higher Education. And you can imagine how impossible for me was what I have learned at CERN concerning international cooperation, planning big experiments, thinking about big budgets, and all the skills I have already mentioned on my previous slides. So. Also, it was important for me that during this service, I supervised Polish. Well, in fact, I cooperated closely with Polish Space Agency on scientific projects for space missions. And in fact, in February this year, I became president of the Polish Space Agency. And so I came back to my interest from the childhood, and I really used all the skills, both the soft and hard, from zero experience. I already mentioned to you, for example, rad-hard designing of rad-hard electronics. I mentioned this international cooperation, really long-term projects, and so on. So that's the end of my story, and I'd like to finish this with a message for you. With a message about what I call CERN atmosphere, because I have seen at CERN things you can anywhere else. I mean, professors solving problems jointly, prominent scientists and technicians taking shifts together. I mean, friendly cooperating scientists from countries officially at war. Literally, I have seen such a situation when when physicists from a certain country applied for a partnership in a big collaboration, and physicists from another country stood up and said, "I'm sorry, I am obliged by my government to vote against, but I hope that we could friendly collaborate, and I see no problem in friendly cooperation between us on the working level." So it was really amazing, and I wish all the organizations, have the same spirit, the same atmosphere. So all this is possible because of this CERN atmosphere. And let me just mention 3 components of that. Well, one is meeting great challenges of humankind by joining international effort, effective use of contributions from big and small countries. I remember that collecting all contributions for the sea experiments, we were very careful for every smallest country, because we have collected those contributions from so many countries, we were able to complete our detector. And then last but not least, one team spirit. Really, we always work as a one team. There was no unhealthy competition or something like that. So I believe that spreading this atmosphere through the world is so much needed today, because we are facing difficult global challenges. I don't need to mention that, you know them very well. So I believe that this is just the mission of CERN alumni, to spread this atmosphere to the places you work, to the countries you live, to your families, to your children, to your colleagues, everywhere. Thank you.
Thank you, Grzegorz. That was a really fascinating talk. And now I'm sure that people will have plenty of questions for you. We'll try to cover as many as possible. And for those questions we don't manage to get through, the professor has kindly agreed to take part in the networking tables from R1 from 1915 to talk more. But let's start with a few questions on the subject. So the first question I have is on the Pie of the Sky. Could you tell us a little bit more about it, about which type of detector was used and the technology behind it?
Sure. We have developed our own CCD cameras for that because it was necessary to take pictures with very short exposures. I mean, short concerning astronomy. In astronomy, usually you take one pictures for half an hour or so, whereas we took pictures every 5 seconds or every 10 seconds. Therefore, it was necessary to design a shutter which can withstand, hundreds of thousands of closing and opening. And we have done a very smart thing. We just took hard disks and we used the device which is moving the head in the hard disks, and we attached to that, a sheet of metal. And in this way, we manufacture shutters for those cameras. So this is just an example how different problems need to be solved in a non-standard way. Okay. And then what was important, that the amount of data we have collected this way, with cameras covering a big part of the sky and making pictures every 5 or 10 seconds. So this huge amount of data was not possible to send to analyze in Poland from Chile, especially the link from Chile to Poland was not very good. Therefore, the analysis was done in almost real time, and only selected events, selected portion of the pictures were saved and sent to Warsaw for the detailed analysis. Also, we were connected to this to so-called GCN network, sending the signals from the satellites observing gamma ray bursts in gamma rays. So we reacted to the triggers, but our ambition was that we should look at the place before that, so we can observe the rising edge of the light curve of the objects. So you have seen the picture of the cameras on Las Campanas, and we operated there for several years. We have seen a couple of gamma ray bursts. We have we observe a lot of variable stars and things like that. I think this answers your question.
Thank you. The next question we have for you is, what do you think of the commercial space flights that have recently been taking place?
I appreciate them because this is the stream of money which comes to the space sector. Thanks to that, we can develop new technologies. We can use this money to advance technology and also to advance science. So I think it's a very good opportunity that some people could subsidize research and development of this technology, exchange of the flight.
Yeah, yes, I agree with you. Another question I would have for you now, as president of the Polish Space Agency, where do you sit, in these times of difficult funding at governmental level, where do you see the role of, let's say, applied science missions as opposed to sort of fundamental science? How do you position yourself on that debate at government level?
Right. Concerning the scientific flights, those are usually big and expensive missions. Therefore, those missions are organized by the big international agencies like European Space Agency, and Poland is participating actively in those, and in international cooperation with NASA, with other space agencies. So we contribute to that, but even if the goal of the mission is purely scientific, it always needs to develop special technologies, new devices, new materials, new kind of algorithms, and so on. So even purely scientific mission is also a technological mission, and also an opportunity for companies, especially small growing, to get flight heritage and to earn money as well. Whereas, on the other hand, we have the use of the space. We have a lot of applications like Earth observation, for example, when from the space we can see what's going on the Earth, we can plan our agriculture, we can look for some possible signs of the catastrophe, and so on and so forth. And for those commercial activities, there is a big need, and now we are facing creation of a real market. So we call this phenomenon new space because the technology now enables a satellite of the size of the shoebox to do the same, which a few years ago it was possible with a satellite of the size of a bus. So now even small companies, even students, they can make their own satellites. So the number of companies is growing, and we observe a real market. But there is a mutual connections between the two. So as I said, scientific missions stimulate the development of the technology, and the commercial use makes the technology easier available and cheaper for scientific missions.
So, following on from that question, the next question is, what do you see as the priority for the Polish Space Agency and maybe also the European Space Agency over the next decade?
We are just preparing a Polish space program right now, and it is concentrated on addressing the needs of modern country, of modern society, the needs for, I mentioned Earth observation, but also telecommunication, navigation, and so on, to address those needs with the technology we develop. That means a sort of a byproduct should be the development of a new branch of economy, in fact, creating this market and developing this market even further. But of course, as I said, answering the previous question, this market to start, to get a flight heritage, to develop, needs some injection of money from those large international projects we participate in. So the priority for Poland is, both to have greater participation in European Space Agency missions, not only providing components but subsystems and systems for the satellites, plus having our own satellites, having our own infrastructure on the Earth to provide benefits from the space technology to the country, to the citizens.
Thank you. The next question, with your background, I think it's a very interesting one. What are you particularly looking forward from the James Webb telescope mission that is upcoming?
I don't know, but the most interesting observation of the deep space for me was in fact combination of supernovas, and other objects, distant supernovas and other objects, to study the early expansion of the universe. So from that we can predict whether the universe will end up with just growing and growing and growing forever, or a big crunch which will be at a certain date, and so on and so forth. So in fact, it's a prediction of the date of the end of the world.
Thank you. I think that's really interesting. Sorry if we didn't get through all the questions. I think so many people were interested in the talk. I think it's interesting we end with CERN, we often talk about going back as far as we can, close to the Big Bang, and now we ended this talk with thinking about the end of the world. So I think we've covered everything there is possibly to cover. Thank you so much.
Thank you very much.